Hi everybody, this is Mr. Yeoman, and today what I want to do is go through a practice problem of how to solve a limiting reactant problem. Okay, so the problem that's been given to us is if 1.85 grams of magnesium hydroxide reacts with 3.71 grams of hydrochloric acid, how much magnesium chloride is produced? What is the limiting reactant? Okay, so the first thing that we need to be looking for is what is the question asking? And so there's really two questions here. They want to know how much magnesium chloride is going to be produced, and from that we can also determine what the limiting reactant is going to be. Um, but then we also need to identify what information is important to us. So looking at the beginning of this problem, if 1.85 grams of magnesium hydroxide reacts with 3.71 grams of hydrochloric acid, it's a pretty good guess that those two numbers are going to be important for us. And in fact, they are because those are our reactants. So I'm going to go ahead and circle those two. Okay, so we're going to use the 1.85 grams of magnesium hydroxide. Then we're also going to be using 3.71 grams of hydrochloric acid. So that's what we know. Okay, the thing that we don't know is how much magnesium chloride is being produced. But we need a little bit more information to really solve this. We're going to need to get a little bit more information because even though what we've circled so far is very relevant, is essential to us answering this, we also need a balanced equation. So if we take magnesium hydroxide and react that with hydrochloric acid, we get these two products, magnesium chloride and water. Now, this in itself isn't quite enough. We also need to balance it. So looking at our problem, we know that we have two oxygens on the reactant side, and only one oxygen on the product side. So we're going to need to balance that out. In that process, we end up with a 2 in front of the hydrochloric acid and a 2 in front of the water. Okay, so now that we have a balanced equation, this is going to be very relevant information for us as well. Okay, so now that we have our knowns, as well as our unknown, which is how much magnesium chloride is produced, then we also need to figure out what's our method to solving this problem. Okay, so what we've been started with is the number of grams of a substance. Okay, so I'm going to call that substance A, okay, because this is very generic. Even though we are talking about something specific here, we could apply this to anything. So we're going from grams of substance A, and we can go to other substances from this. Okay, so if you look back to that graphic organizer that I gave you, that's in the front of your packet, going from grams, a very convenient thing that we can move into are moles. And we can go from grams of that substance into moles of that same substance using the molar mass or formula weight. Okay, so if we know the molar mass of substance A, we can go from grams into moles. Okay, now that's great, except in our question, we want to go from magnesium hydroxide into magnesium chloride, or from hydrochloric acid into magnesium chloride. So that means that we need to get into a different substance. So we also know how to do that. We know how to go from moles of one substance into moles of another substance. So that's going to be part of our method to solving this problem, is going from grams of A into moles of A, and from moles of A into moles of B. But Mike, you say, how do we do that? How do we go from moles of one substance into moles of another? Well, that's why we have our handy-dandy balanced equation there, is because from that balanced equation, we can take the mole ratio and determine what's the relationship between these two compounds. Okay, so that gives us moles of our second substance, what we're going to call B. And even though moles are a very useful tool, we generally want to do this in grams so that we can actually determine, how much we have there. It's sometimes difficult to just look at something and say, well, not sometimes, it's often difficult to look at a substance and say, oh, this is that many moles. It's much easier to put it on a scale and say that we have a number of grams. So that's what we're going to do, is we're going to get this back into grams of that substance. In addition to that, we can do the same thing that we did in our first step, going from grams to moles, going from moles to grams is essentially the same thing. We're just going to flip-flop what our fraction looks like. But we're still going to be using the molar mass, just the molar mass of whatever this substance is. In this case, it'll be magnesium chloride. Okay, so we have the question. We know what the problem is asking. We have our knowns and our unknowns, so we have that information. We have determined what information is important and what is not necessarily important. This one we don't have a whole lot of extra information. Probably the only extra information that we have is that there's water in the equation, because that's not something that has been referred to. But other than that, there's some problems there's quite a bit of excess information, and we just don't have that in this particular problem. So we've determined what is essential and what is not essential, and we've come up with a method to solve that. So now it's just going through and actually solving that problem. So looking at our 1.85 grams of magnesium hydroxide, I can put that down, and as we said many other times, we can also put that over 1, because that is the same thing. And so we're going to go from grams of magnesium hydroxide into moles of magnesium hydroxide, and we do that using the molar mass, which is 58.32 grams per mole of magnesium hydroxide. Okay, so if we were to solve right now, we would be in moles of magnesium hydroxide. But that's not really what we want. We want to be in magnesium chloride, which is stated right up here at the top of our question. So we need to convert from moles of magnesium hydroxide into moles of magnesium chloride. And as we looked at just above here, in solving this problem, we need to use that mole ratio. And so we can see that the relationship between magnesium hydroxide and magnesium chloride is 1:1. So we can put that right in here and have 1 mole of magnesium chloride over 1 mole of magnesium hydroxide. Okay, so now that we're in moles, we can now move into grams. And we can go about that the same way that we went from grams of A into moles of A, except it's going to be reversed. As I said earlier, it's going to be just like this, where we use the molar mass, except in this case, instead of the molar mass of magnesium hydroxide, we're going to use the molar mass of magnesium chloride, or the formula weight. And the formula weight of magnesium chloride is 95.21 grams per mole. And so now we can just solve, which would take 1.85 divided by 58.32 times 1 divided by 1 times 1 divided by 1 times 95.21, which gives us 3.02. And as we've always done, we go through and cancel out our labels. So those two cancel, those two cancel, those two cancel, leaving us with grams of magnesium chloride. Okay, so that solves what we need for the first portion. But as we discussed earlier, in order to determine the limiting reactant, we need to solve for both of the reactants there, because we don't know how much of each one is going to be used necessarily. So I can repeat this entire process with hydrochloric acid. So again, I start with my 3.71 grams of hydrochloric acid. If I want to, I can put that over 1. And now I'm going to do the same thing. I'm going to divide by the molar mass of hydrochloric acid, which is 36.46 grams per mole. And then we can move on into our mole ratio. Now this has a different mole ratio because there are 2 moles of hydrochloric acid for every 1 mole of magnesium chloride. So that's going to change our numbers a little bit, and so that's going to change our math as a result. Okay, so now we're in moles of B. In this case, that's magnesium chloride, but we want to get that into grams. So this step is going to look just like the one right above it, because the formula weight of magnesium chloride hasn't changed. So we're just going to plug this back in, and then we solve, which is 4.84. And again, if we want to go through, you should be able to identify that if you've done it correctly, then our grams of magnesium chloride should be our label, but we can just double check that and say, all right, grams of hydrochloric acid and grams of hydrochloric acid cancel out, moles of hydrochloric acid cancel out, moles of magnesium chloride cancel out, leaving us with grams of magnesium chloride, which is our answer. So we've done about 3/4 of the work now. We really have one step left, probably more than 3/4 of the work. So we just have one step left here, and that's to determine which one is our limiting reactant. And what these two equations are telling us is that if all 1.85 grams of magnesium hydroxide are reacted, we would get 3.02 grams of magnesium chloride. If all 3.71 grams of hydrochloric acid were reacted, we would get 4.84 grams of magnesium chloride. So that is telling us that if we're mixing these two things together, the maximum amount of magnesium chloride we can get is 3.02 because that is the smaller of the two numbers. So that makes magnesium hydroxide our limiting reactant. So this would be our expected yield, or our theoretical yield would be that 3.02 grams of magnesium chloride in this situation. All right, thank you very much for your time. Tomorrow we'll lead in and start talking about how to find percent yield of a reaction. So thank you. We have some practice problems to work on, and I will see you tomorrow.